July 23, 1943. Kursk, Russia. Obergefreiter Heinrich Müller stood in the captured American Dodge truck, staring at the engine compartment with an expression that mixed professional admiration with existential dread. Müller had been a master mechanic at a Mercedes-Benz factory before the war. He understood engines the way poets understand words. And what he was looking at, a Ford GAA V8 engine that had somehow found its way into a Lend-Lease truck delivered to the Soviets, told him something that no amount of propaganda could hide. Germany had already lost the war. Herr Obergefreiter, what's wrong? Private Werner Schmidt, Müller's assistant, couldn't understand why his normally stoic supervisor looked like he'd seen a ghost. It's just an American truck engine. We've captured hundreds of vehicles. Müller ran his hand along the engine block, feeling the precision of the casting, examining the simplicity of the design, calculating the implications of what he was seeing. Werner, this engine is mass-produced. You understand what that means? This isn't a precision-crafted motor built by skilled machinists. This is stamped out by the thousands in factories using assembly line techniques, and it's better engineered than anything we make. He pointed to the valve train. Look at this. Overhead valves, hydraulic lifters, self-adjusting clearances. Our engines require constant manual adjustment by trained mechanics. This engine adjusts itself. A peasant conscript can maintain this. He touched the carburetor. Single downdraft carburetor, feeding all 8 cylinders evenly. Our V12s need multiple carburetors and constant tuning. This just works. But what truly devastated Müller was the manufacturing evidence he saw in the engine's construction. The casting quality suggested automated foundry processes. The machining showed precision, achievable only with mass-produced tooling. The assembly indicated modular construction, where parts were interchangeable between engines. Every aspect of this engine demonstrated industrial capacity that Germany couldn't match. Werner, the Americans built this engine in a factory that probably produces 1,000 of them per week. They put it in a truck they gave to the Russians for free. For free, Werner. They have so many trucks and so much industrial capacity that they can give them away. And this truck, this cheap Lend-Lease vehicle the Americans consider expendable, has a better engine than the one in the Führer's personal Mercedes. What Müller had discovered, what Wehrmacht mechanics across the Eastern Front were discovering as they captured and examined American equipment, was that the industrial war had already been decided. The mathematics of production, the quality of manufacturing, and the sophistication of American mass production techniques meant that Germany was fighting an enemy who could produce better equipment faster and in greater quantities than Germany could ever hope to match. This is the story of how one captured engine revealed the truth that propaganda tried to hide. It's about German mechanics who understood that industrial warfare would be won not by the best engineers, but by the best factories. And it's about the moment when experienced German technical personnel realized that their nation was attempting the impossible, defeating an industrial colossus with boutique manufacturing. The Ford GAA V8 engine that shattered Heinrich Müller's confidence in German victory was a masterpiece of American industrial engineering. Designed in 1941 specifically for tank applications, it produced 500 horsepower from its 1,100 cubic inch displacement. But the real innovation wasn't the power output. It was the manufacturing methodology that allowed Ford to produce these engines at a rate of 1,500 per month by 1943. The engine's design prioritized manufacturability over theoretical perfection. German engines, designed by brilliant engineers pursuing optimal performance, required hundreds of precision machined parts assembled by skilled technicians. The Ford GAA, designed by engineers who understood mass production, used fewer parts, simpler assemblies, and manufacturing techniques that could be automated. The result was an engine that was slightly less powerful than German equivalents on paper, but far more reliable in practice and exponentially easier to produce in quantity. Müller's expertise let him recognize these details. The engine block was a single aluminum casting, a manufacturing technique requiring sophisticated foundry equipment, but enabling rapid production once the tooling was created. German tank engines used multiple cast iron sections bolted together, heavier, more complex, and more time-consuming to manufacture. The Ford single-piece construction was lighter, stronger, and faster to produce. The crankshaft was forged steel, machined on automated equipment, to tolerances that would have required hand-fitting in German factories. The connecting rods were I-beam construction, stamped from steel plate and machined in high-volume processes. The pistons were aluminum, precisely cast and requiring minimal hand finishing. Every component showed evidence of design for automated manufacture. But what truly horrified Miller was the interchangeability. He knew from his Mercedes-Benz experience that German engines required selective fitting. Parts were manufactured to tolerances, then technicians would select parts from bins, measuring and matching components to create proper clearances. A crankshaft from one engine wouldn't necessarily fit another engine without adjustment. A piston from one engine might not fit another without selective fitting of rings and pins. The Ford engine's parts were completely interchangeable. Any crankshaft fit any block. Any piston fit any cylinder. The tolerances were tight enough that parts could be assembled randomly and would work perfectly. This meant American factories could produce parts in massive quantities, ship them anywhere, and field mechanics could assemble or repair engines using parts from supply without worrying about fitting or adjustment. "Do you understand what this means, Werner?" Miller's voice carried the weight of terrible realization. "This means the Americans can repair their tanks in the field using parts from supply. We need specialized technicians and custom fitting for repairs. They need a wrench and a supply sergeant. Their logistics are simplified by design. Ours are complicated by precision." The implications extended far beyond maintenance. The design philosophy that created the Ford GAA, prioritizing ease of manufacture and field serviceability over theoretical perfection, represented thinking that German engineering culture couldn't accept. German engineers were trained to create optimal solutions. American engineers were trained to create producible solutions. In industrial warfare, producible beat optimal every time. Muller began documenting what he found, writing detailed technical notes that would later be discovered in Wehrmacht archives. His analysis was devastating in its clarity. He measured the engine's bore and stroke, calculated the compression ratio, examined the metallurgy of components, and assessed the manufacturing techniques used in every part. His conclusion, written in precise technical language, was damning. American automotive industry demonstrates manufacturing capacity and sophistication that Germany cannot match. Enemy produces engines of adequate performance in quantities we cannot approach using techniques we do not possess. Implications for war outcome are negative. But Miller wasn't the only Wehrmacht mechanic reaching these conclusions. Across the Eastern Front, as American Lend-Lease equipment poured into Soviet hands, German technical personnel were capturing and examining this equipment. And everywhere, the same realizations were happening. German mechanics who understood what they were seeing knew that Germany was attempting the impossible. In Ukraine, Oberfeldarzt Karl Fischer, a medical officer who had been an automotive engineer before the war, examined a captured Studebaker US-6 truck. The truck was crude by German standards, with simple leaf-spring suspension, basic transmission, and unrefined ride quality. But Fischer's engineering eye saw past the lack of refinement to the underlying genius. The truck was designed to be manufactured by the tens of thousands using simple tools and unskilled labor. The parts count was minimized. The assembly could be done by workers with minimal training, and it worked reliably under conditions that would destroy more sophisticated vehicles. Fischer wrote in his diary, "The Americans understand something we do not. They have accepted that war requires quantity over quality. Their trucks are not refined, but they are adequate and they exist in numbers we cannot comprehend. I saw today a supply convoy of 400 American trucks carrying supplies to Soviet forces. 400. Our entire Army group has perhaps 200 trucks total, and half are inoperative, awaiting parts. The Americans give 400 trucks to the Soviets in a single convoy and consider it routine. In Belarus, Hauptfeldwebel Otto Reinhardt, a tank mechanic with 15 years' experience at Porsche, examined a captured Sherman tank. He had been told by propaganda that American tanks were inferior, crude vehicles that German Panthers and Tigers would destroy easily. The technical reality was more complex and more disturbing. The Sherman's armor was indeed thinner than German heavy tanks. Its gun was less powerful. But Reinhardt's mechanical inspection revealed advantages that mattered more than armor and guns. The Sherman's engine was reliable and easy to maintain. Its transmission was robust and simple. Its suspension was unsophisticated but practically indestructible. The entire vehicle was designed for rapid field repair using interchangeable parts. Reinhardt opened the Sherman's engine compartment and was stunned by the simplicity. Everything was accessible. Maintenance points were clearly marked. Parts could be replaced without specialized tools. He compared this to German tanks, where engine removal required cranes, transmission repair, needed specialized technicians, and parts were custom-fitted during manufacture. The Sherman could be maintained by soldiers with basic training. German tanks required factory-trained specialists. American tanks are not better tanks, Reinhardt told his crew. They are better weapon systems. A weapon system includes the vehicle, the maintenance, the logistics, the training. The Sherman system is superior to our system, not because the tank is better, but because the Americans can field 10 Shermans for every one of our Panthers, maintain them with less effort, supply them with less complexity, and replace them faster when destroyed. We can destroy 5 Shermans before they destroy our Panther, but they can replace those 5 within a week. We cannot replace our Panther at all. If you're fascinated by these revelations about industrial warfare and the technical details that determine the war's outcome, make sure you subscribe to our channel and hit that notification bell. We bring you the detailed analyses of how production capacity shaped history. Don't miss our next deep dive into the weapons that won through quantity. The cumulative effect of these individual revelations was a growing awareness among Wehrmacht technical personnel that Germany's industrial capacity was fundamentally inadequate for the war it was fighting. This awareness spread through informal networks, mechanics talking to other mechanics, engineers sharing observations, technical personnel comparing notes. And everywhere, the conclusion was the same. America's industrial sophistication was beyond German capability to match. The specific numbers that Heinrich Müller calculated after examining the Ford GAA engine were sobering. Based on the manufacturing evidence he saw, he estimated that Ford could produce this engine at a rate of approximately 30 engines per day per factory. He knew Ford had multiple factories. Conservative estimate, 100 engines per day. 3,000 per month, 36,000 per year. From one company, one engine type. Miller knew that all of Germany's tank engine production, from all manufacturers combined, totaled approximately 18,000 engines per year in 1943. Half of what he estimated Ford alone was producing, and Ford's engines showed better manufacturing quality, better interchangeability, and better field serviceability. The implications were clear. Germany was attempting to fight an enemy with twice the production capacity using techniques that were superior in every measurable way. But the problem extended beyond engines. German mechanics examining captured American equipment found the same patterns everywhere. Weapons were designed for mass production. Vehicles were designed for field maintenance. Everything showed evidence of industrial processes that Germany didn't possess or couldn't implement at sufficient scale. The M1 Garand rifle, standard American infantry weapon, was examined by Waffenmeister Peter Kruger, a gunsmith before the war, who now maintained Wehrmacht small arms. The Garand was semi-automatic, firing as fast as the trigger could be pulled, compared to German Kar 98K bolt-action rifles requiring manual cycling between shots. But what impressed Kruger was the manufacturing. The Garand required approximately 120 machining operations to produce. The Kar 98K required over 200. The Garand was faster to manufacture despite being more sophisticated technologically. Kruger disassembled a captured Garand and examined each part under magnification. The precision was extraordinary, but it was automated precision, not handcrafted precision. The parts showed tool marks from high-speed machining, suggesting production rates that would be impossible with German manufacturing methods. The interchangeability was perfect. Parts from different rifles were completely compatible. This meant American armories could produce parts in massive quantities and assemble rifles from randomly selected parts. German rifle production required selective assembly and hand-fitting of many components. The Americans have solved manufacturing problems we still struggle with, Kruger wrote in his report. Their weapons are not better because their engineers are more clever. They are better because their manufacturing processes are more advanced. They have mechanized and automated production to levels we have not achieved. The result is weapons of good quality produced in quantities we cannot match. The industrial sophistication extended to the smallest details. German mechanics examining American vehicles found that even the fasteners, the bolts, and nuts holding equipment together were superior. American fasteners were hardened steel, precisely threaded and fully interchangeable. German fasteners varied in quality, often required hand-fitting, and frequently failed under stress. This detail, seemingly trivial, had enormous impact on field maintenance and reliability. Obergefreiter Hans Weber, a mechanic maintaining German trucks in Italy, kept an informal journal documenting the differences he observed between German and captured American vehicles. His entries revealed cumulative recognition of American industrial superiority. June 15, 1943. Examined captured American Jeep. Vehicle is crude, uncomfortable, and unsophisticated, but it starts reliably, drives through terrain that would stop our Kubelwagen, and requires almost no maintenance. The engine is simple but adequate. The transmission is basic but robust. Everything about this vehicle suggests it was designed to be used by soldiers who are not mechanics. Our vehicles require constant attention from trained technicians. This Jeep can be driven by anyone and maintained by anyone. July 3, 1943. Requisitioned American spare parts from captured supplies. All parts fit perfectly without adjustment. We installed American spark plugs in a Jeep. They fit multiple different vehicles we captured. German spare parts are vehicle-specific and often require hand-fitting. The Americans have standardized even small components for interchangeability. This suggests industrial planning and capacity we do not possess. August 9, 1943. Compared American truck engine oil filter to German equivalent. American filter is disposable, screwed on, replaced in minutes by anyone. German filter requires disassembly, cleaning, and reassembly by mechanic. American design assumes filters are cheap and labor is expensive. German design assumes labor is cheap and parts are expensive. This difference in assumptions reveals different industrial capacities. Americans can afford to make parts disposable because they can produce them in such quantity that cost is negligible. Weber's observations revealed a fundamental difference in design philosophy. German equipment was designed by engineers who assumed that skilled technicians would maintain it, that parts were valuable and should be repairable, and that complexity was acceptable if it achieved performance. American equipment was designed by engineers who assumed that users would be minimally trained, that parts were cheap and should be disposable, and that simplicity was more important than theoretical perfection. In industrial warfare, the American philosophy was decisively superior. The recognition that America's industrial capacity was overwhelming wasn't limited to mechanical equipment. German quartermasters examining captured American supplies found the same patterns. The packaging was standardized. The rations were designed for mass production. Even the cigarettes showed evidence of industrial sophistication beyond German capacity. Hauptmann Friedrich Schneider, a quartermaster officer in Army Group Center, examined captured American C rations and was simultaneously impressed and depressed by what he found. The rations were packaged in tin cans, manufactured with precision that suggested highly automated production. The contents were standardized, nutritionally balanced, and designed for long storage. The variety was extensive, with multiple meal options suggesting production capacity that could afford specialization. Schneider compared this to German field rations, which had degraded significantly by 1943. German rations were increasingly simplified, portions were shrinking, and variety had disappeared. The reason was manufacturing capacity. Germany couldn't produce enough food, couldn't package it adequately, and couldn't distribute it reliably. The contrast with American abundance was stark. The Americans feed their soldiers better in the field than we feed ours in garrison, Schneider wrote. Their rations include luxuries we cannot provide: candy, cigarettes, coffee. The psychological impact of this on our soldiers who capture American supplies is devastating. They see that the enemy eats better, smokes better cigarettes, and has equipment that works better. This destroys morale more effectively than propaganda can rebuild it. The cigarettes were particularly significant. Wehrmacht soldiers who captured American cigarettes found them superior in quality and packaging to German cigarettes. The tobacco was better cured, the cigarettes were more consistently manufactured, and the packaging was moisture-resistant. These details suggested that American industrial capacity extended to consumer goods production, with sophistication that Germany couldn't match even in military applications. The psychological impact of these cumulative discoveries was profound. Wehrmacht technical personnel who understood what they were seeing began recognizing that Germany was attempting an impossible task. They were trying to fight an industrial war against an enemy whose industrial capacity was an order of magnitude superior. Every captured piece of American equipment was a reminder of this disparity. Some responded by maintaining faith in German technological superiority. They argued that German weapons, while produced in smaller quantities, were superior in quality. A German Tiger tank could destroy 5 Shermans. A German Kar 98K rifle was more accurate than an M1 Garand. German engineering excellence would overcome American industrial brute force. But the mechanics, who worked with the equipment daily, knew this was wishful thinking. Heinrich Müller, after his devastating encounter with the Ford GAA engine, began tracking information about American production capacity. He collected estimates from intelligence reports, interrogations of captured Americans, and analysis of captured documents. The numbers he compiled were so extraordinary that he initially thought they must be propaganda exaggerations. American aircraft production, 96,000 aircraft in 1943. German production, 25,000. American tank production, 29,000. German production, 12,000. American truck production, 620,000. German production, 70,000. Every category showed American production exceeding German production by factors of 2 to 8. But Muller's mechanical expertise let him understand that these numbers were not just possible. They were probable based on what he saw in captured equipment. The manufacturing techniques evident in American equipment suggested industrial capacity consistent with these production numbers. The automation, the standardization, the interchangeability all indicated production systems designed for massive volume. "We are not fighting the American military," Mueller told his crew. "We are fighting American industry, and American industry is producing weapons faster than we can destroy them. The mathematics are simple and terrible. They produce 3 tanks for every one we produce. They need only a 3-to-1 numerical advantage to offset any technical superiority we possess, and they have that advantage in every category. We cannot win through better engineering. We can only win if they stop producing, and there is no indication they will stop." The reports from Wehrmacht technical personnel examining American equipment filtered up through command chains but were often dismissed or suppressed. Field Marshal Albert Kesselring, commanding German forces in Italy, received multiple reports from mechanics and engineers documenting American industrial superiority. He forwarded these to High Command with his own assessment. The enemy demonstrates industrial capacity and manufacturing sophistication that exceeds our own by significant margins. Continued operations against this enemy require either closing this industrial gap, which appears impossible, or achieving decisive military victories that end the war before industrial advantages become decisive. Time is not on our side. Kesselring's assessment was accurate, but was largely ignored by High Command. Hitler and his inner circle dismissed American industrial capacity as irrelevant, believing that German military superiority and willpower would overcome material disadvantages. This dismissal of technical reality in favor of ideological fantasy characterized German strategic thinking throughout the war. If you haven't subscribed yet, now is the perfect time. Click that subscribe button and ring the notification bell so you never miss our detailed explorations of how industrial capacity shaped World War II. We have more incredible analyses coming your way. The mechanics and engineers who recognized the reality couldn't change strategic decisions, but they could adapt tactically. Wehrmacht maintenance units became expert at cannibalizing captured American equipment for parts. The interchangeability of American components meant that captured spare parts could keep multiple vehicles running. German units operating American vehicles they had captured found them more reliable and easier to maintain than German equipment. Some German units actually preferred captured American vehicles to German equivalents. The reliability, the ease of maintenance, and the availability of captured spare parts made American vehicles attractive, despite propaganda declaring them inferior. This preference among German soldiers for enemy equipment was noted in reports and considered demoralizing by command. The end of the war brought full revelation of the industrial disparity German mechanics had recognized. When Allied forces occupied German factories, they found production facilities that were sophisticated but limited in scale. German automotive factories, even major producers like Mercedes-Benz and BMW, operated at scales that were small by American standards. The tooling was precise, but not designed for mass production. The workforce was skilled but not organized for assembly line efficiency. American technical teams examining German factories wrote detailed reports. The assessments were respectful of German engineering skill, but noted that German manufacturing philosophy was fundamentally unsuited for industrial warfare. German factories were designed to produce high-quality products in moderate quantities. American factories were designed to produce adequate quality products in massive quantities. In total war, massive quantities beat high quality. Heinrich Miller survived the war and returned to Mercedes-Benz. In a 1952 interview with an automotive trade magazine, he reflected on his wartime experience. When I examined that American Ford engine in 1943, I knew the war was lost. The engine itself wasn't revolutionary. What was revolutionary was that Americans could produce it in quantities we couldn't imagine using techniques we didn't possess. I was trained to admire engineering excellence. The Ford engine taught me that manufacturability is more important than theoretical perfection. The Americans won the Industrial War before the military war was decided. We mechanics understood this before the generals did. Otto Reinhardt, the tank mechanic who had examined Shermans, also survived and went to work for Porsche after the war. He helped design the Volkswagen Beetle, incorporating lessons learned from American mass production techniques. In a 1965 interview, he was explicit. American automotive industry taught us that simplicity and mass production were more valuable than complexity and precision. The Beetle was designed using principles I learned from examining American vehicles during the war. Easy to manufacture, easy to maintain, reliable rather than sophisticated. These American principles made the Beetle successful. DWWII. The post-war German automotive industry rebuilt using lessons learned from studying American manufacturing during the war. German engineers who had examined captured American equipment understood that peacetime competition would require mass production techniques Germany hadn't possessed before. The economic miracle of West Germany's industrial recovery was built partly on adopting American manufacturing philosophies that Wehrmacht mechanics had first encountered in captured equipment. The broader historical lesson is about the nature of industrial warfare. Technical sophistication matters, engineering excellence matters, but manufacturing capacity and producibility matter more. Germany had excellent engineers who designed superior weapons. America had excellent engineers who designed producible weapons. The difference determined the war's outcome. The Wehrmacht mechanics who examined captured American equipment understood this before most others. Their technical expertise let them recognize that the Ford GAA engine, the Sherman tank, the M1 Garand rifle, and the Jeep represented not just individual weapons, but a manufacturing philosophy that Germany couldn't match. They understood that trying to defeat American industry with German boutique manufacturing was attempting the impossible. The tragedy was that this understanding didn't change German strategy. The mechanics who knew Germany couldn't win industrially continued doing their jobs, maintaining equipment, training crews, and supporting operations they knew were futile. Professional duty required doing the job well, even when success was impossible. But the knowledge that their efforts were ultimately futile weighed heavily on men who understood the mathematics. The psychological burden of knowing defeat was inevitable, while continuing to fight was significant. Heinrich Müller described it decades later. After I examined that engine, every day felt like delaying the inevitable. I knew we would lose. I knew American production would bury us under quantities we couldn't match. But I was a soldier. I had duties. So I maintained our vehicles, trained my crews, and did my job while knowing it wouldn't matter in the end. That knowledge was the worst part of the war. Not the fear or the hardship, but knowing that everything we did was futile. This existential awareness among technical personnel who could calculate the mathematics of production and understand the implications was more common than records indicate. Many Wehrmacht mechanics, engineers, and technical specialists reached similar conclusions after examining American equipment. They didn't discuss it openly, as such defeatism was dangerous, but they understood, and their understanding created a subtle demoralization that no propaganda could overcome. The final assessment is that Wehrmacht mechanics who examined the Ford GAA engine and other American equipment gained insight that strategic leadership lacked. They understood that industrial warfare would be decided by factories, not battlefields. They recognized that American manufacturing capacity and sophistication exceeded Germany's by margins that couldn't be overcome through military brilliance or technological superiority. And they knew, often years before the war ended, that Germany had already lost the industrial war that would determine the military war's outcome. Heinrich Müller's devastating realization in July 1943, standing before a captured Ford engine, was repeated thousands of times across the Wehrmacht as technical personnel examined American equipment. Each examination revealed the same truth. Germany was fighting an enemy whose industrial capacity was insurmountable. The Ford GAA engine, mass-produced by the thousands, given away to allies technically sophisticated yet manufacturable by unskilled workers, represented a level of industrial achievement Germany couldn't approach. The Wehrmacht mechanics who recognized this truth couldn't stop the war, but they understood it was unwinnable years before the political leadership admitted defeat. Their expertise gave them insight that ideology obscured for others, and their knowledge that they were fighting a losing battle while professional duty required continuing that fight created a burden that many carried for the rest of their lives. The captured Ford V8 engine that broke Heinrich Müller's confidence in German victory was eventually destroyed, probably in a bombing raid or abandoned during retreat. It was one engine among millions produced by American factories. Its technical specifications were unremarkable, but its existence and what it revealed to those with eyes to see represented truth more devastating than any propaganda. Germany had challenged an industrial giant, and the mathematical certainty of defeat was evident in every captured piece of American equipment. The mechanics understood this long before the generals, and their understanding passed through informal networks, spread awareness that the war was unwinnable, even as official propaganda proclaimed inevitable victory. Sometimes the most important intelligence comes not from spies or signals intercepts, but from mechanics who understand what they're seeing when they examine captured enemy equipment. The Ford GAA engine was such intelligence, and what it revealed was simple and terrible. Germany could never win